Do you like mysteries? To wander through the enigmatic mist of the inexplicable? Great. I'm Merc, and here you'll find what you're looking for. Welcome to my domains. The truth dissolves into the mist.
It arrived from the direction of Sagittarius, a ghost appearing in the data streams of the Atlas Survey Telescope in Chile on the 1st of July, 2025. At first, it was just another point of light, a pixelated smudge against the backdrop of the cosmos. But as astronomers plotted its trajectory, a cold certainty began to dawn on them. This was not a local rock. This was an interloper, a visitor from another star, only the third ever detected. They named it 3IATLAS, tick. For months, the world watched as it plunged toward the inner solar system, a dark comet screaming through the void at 210,000 kilometers per hour. It was classified quickly, a formality, another comet. But then, the Harvard physicist Avi Loeb looked closer, and what he found was not a list of characteristics, but a catalogue of anomalies, 12 signals hidden in plain sight, signals that suggest we are not merely observing a ball of ice, but perhaps the most significant event in human history unfolding silently near Jupiter. The first anomaly is the trajectory itself. 3.1. Atlas does not move like a random wanderer. It travels in a retrograde orbit, meaning it moves opposite to the direction of the planets, a high-risk highway through the solar system. Yet, despite this, its path is aligned to within 5 degrees of the ecliptic plane, the flat disk where all the planets reside. Statistically, the probability of an inbound interstellar object randomly aligning this perfectly with our planetary disk is less than 0.2%. It suggests a map was used, a target was chosen. See. The second anomaly emerged as it approached the Sun. In July and August, and again in November, telescopes captured an impossible sight, a tail pointing directly at the Sun. In natural comets, the tail is always blown back by the solar wind, a banner trailing behind the nucleus. But here, a jet of material was firing forward, against the wind, into the radiation, an anti-tail for a natural comet. This is a rarity, a trick of light and heavy particles. But in this case, it persisted. It was not a trick, it was a beam. By October, the object reached its perihelion, its closest point to our star, and then it vanished. It passed behind the Sun, disappearing from our view for several critical weeks. Some called it a coincidence, a simple matter of geometry, but the timing was precise. When it emerged on the other side in early December, it was different. It had changed. The third anomaly is the color. As 3IATLAS re-emerged, telescopes recorded a dramatic shift. Typical comets, heated by the Sun, develop a reddish hue, the color of dust and ancient organic material. But 3I Atlas turned blue, not just slightly blue, but a shade bluer than the Sun itself. It brightened at a rate never before witnessed, faster than any known comet from our own Oort cloud. It was as if an engine had been ignited on the far side of the Sun, hidden from our prying eyes. Sit. The fourth anomaly lies in its composition. When scientists analyzed the light from its coma, the hazy cloud surrounding the nucleus, they found metals. Specifically, they found nickel and iron. Finding metals in space is not unusual, but finding them vaporized at such a vast distance from the Sun it takes immense heat to turn metal into gas. Yet here, nearly 300 million miles from the Sun, 3I Atlas was venting a plume rich in nickel, with a ratio of nickel to iron that defies the composition of every known comet. The fifth anomaly deepens the mystery. Among those metals, the presence of cyanide was detected. In comets, cyanide is common. It is often the first molecule to appear as ice worms. But here, the ratio of nickel to cyanide was orders of magnitude higher than in any comet ever observed, including the previous interstellar visitor to I. Borisov. It is the signature of an industrial process, the kind of alloy ratios found not in nature, but in the high-temperature forges of human engineering. The sixth anomaly is the polarization. Light scattering off 3I-ATLAS exhibits a level of extreme negative polarization that is unprecedented in cometary science. It does not reflect light the way ice and dust should. It twists the photons in a way that suggests a surface or a structure unlike anything floating naturally through the void. And then there is the water. The seventh anomaly. The plume surrounding 3I-ATLAS contains only 4% water by mass. In the solar system, comets are defined by water ice. They are muddy snowballs. But this object is dry. It is almost entirely lacking the one ingredient that makes a comet a comet. What we are seeing is not the evaporation of a frozen lake, but the release of something else. Perhaps accumulated interstellar frost burning off the hull of a machine. By November, as 3I-ATLAS approached Earth for its closest flyby, the data became even more disturbing. The eighth anomaly involves its structure. Despite venting material at a tremendous rate, despite the forces acting upon it, the object refused to fragment. Comets are fragile. When heated and spun, they crack, they split, they crumble. But 3I Atlas held together. Its integrity remained absolute. The ninth anomaly is the jet itself. High-resolution imaging revealed that the jet, the anti-tail, was not a diffuse cloud. It was tightly collimated. It shot out in a narrow, focused beam, maintaining its orientation for nearly 1,000,000 kilometers. In nature, outgassing is messy. It spirals. It dissipates. But this beam was precise. A pencil line of matter piercing the solar wind. The 10th anomaly involves spin. Astronomers measured the rotation of the nucleus, clocking it at a precise period between 15 and 16 hours. But here is the contradiction. If the nucleus is spinning, the jet should wobble. It should spiral like a rotating garden sprinkler. Yet the jet maintains its direction. It stays fixed, locked on an invisible target, disregarding the rotation of the body it comes from. That is not a geyser. That is a thruster under active guidance. The 11th anomaly is the acceleration. As it sped away from the sun, 3I Atlas exhibited non-gravitational acceleration. It moved faster than the sun's gravity alone could explain. In natural comets, this happens when outgassing acts like a rocket. But the acceleration profile of this object does not match the observed outgassing. The push is too strong, too efficient. It is as if the energy is not just leaking out, but being directed. The 12th anomaly brings us to the present, and to Jupiter. As 3I-ATLAS sailed through the system, it executed what astrodynamicists call a course correction. Not a wide, sweeping arc, but a fine-tuned adjustment. Its trajectory was nudged, precisely, so that on March 16, 2026, it will pass within 53 million kilometers of Jupiter. That distance is not random. It matches the exact edge of Jupiter's gravitational control, the Hill radius, with a statistical certainty of less than 4/100,000%. This is not a flyby. This is a rendezvous. The object is not passing through the solar system. It is stopping at Jupiter. And if Avi Loeb is correct, it is not stopping to observe. It is stopping to deploy. To understand what is about to happen near Jupiter, you must first understand the concept of a parking spot. In celestial mechanics, there are places where gravity balances perfectly, where an object can hover with minimal effort. We call them Lagrange points. For Jupiter, these points sit at the boundary of its Hill radius, the edge of its domain. It is here that a mothership, if it were a mothership, could release its payload. It is here that sentinels could be stationed. The image captured by astrophotographers in November revealed something that fits this narrative. When Satoru Murata and François Kugel aimed their telescopes at 3I Atlas, they did not just see a comet. They saw structure, multiple jets, oriented in multiple directions, sunward and anti-sunward, not random vents, but a coordinated pattern. Loeb described these as impossible for a natural body, requiring an unreasonably large surface area to absorb enough sunlight to power them. But if the power source is internal, if those are not vents but engines, the math changes entirely. And then there is the question of mass. The nucleus of 3 IATLAS is estimated to be roughly 1 million times more massive than Oumuamua, the first interstellar visitor, and 1,000 times more massive than Borisov. It is a colossus. Statistically, the chance of interstellar space delivering a rock of this size into our inner system once a decade is negligible. It suggests, as Loeb puts it, that this object may have targeted us. It came here on purpose. The purpose, perhaps, is Jupiter. Jupiter is not just the largest planet, it is a shield. It is a gravity well that dominates the system. If you were an intelligence scouting the cosmos, Jupiter would be the obvious vantage point. And on March 16th, 3 IATLAS will thread the needle, passing within a hair's breadth of the Hill sphere. A miss would have meant a slingshot out of the system forever. But the non-gravitational acceleration, the mysterious push, adjusted for that. It was a braking maneuver. We must also consider the geometry of the approach. As 3I Atlas rounded the Sun, its rotation axis was found to be aligned with our star within 8 degrees. The odds of this alignment happening by random chance are 5 in 1,000. This alignment ensured that the antitail, the sunward jet, remained constantly illuminated. It kept the engine warm. It kept the systems running. It is a level of precision that suggests design, not coincidence. Throughout December, as it passed Earth at a safe distance of 170 million miles, every major observatory on the planet was watching. The James Webb Space Telescope, the Very Large Telescope in Chile, the Hubble Space Telescope, all trained their mirrors on this enigma. And what they saw confirmed the anomaly count is growing. Spanish scientists from the Canary Islands have now identified a 14th anomaly. The jet remains collimated, extending 500,000 kilometers without dispersing, like a laser beam of gas. The radio telescopes, like Meerkat in South Africa, have been listening. They have detected signals, of course, but only natural ones, the static of the cosmos. If this is a ship, it is silent. It is running dark. It is observing us without announcing itself. The scientific establishment, including figures like Brian Cox and the teams at NASA, urge caution. They point out that carbon dioxide is abundant, that the metals can be explained by carbonyls, that antitails, while rare, have been seen before. They argue that Occam's razor demands we accept the simplest explanation. It is a comet. A weird one, but a comet nonetheless. But Occam's razor is a tool, not a law, and it is being blunted by the accumulating weight of anomalies. When you have to invent new physics for every new observation, perhaps the simplest explanation is not that nature is behaving strangely, but that we are looking at something not found in nature. Consider the words of Avi Loeb. He reminds us that if this were a human spacecraft, if we had sent a probe to another star, we would make it look like a comet. We would sheath it in ice to protect it from interstellar radiation. We would let it accumulate dust to hide it. And when we arrived at a distant system, we would decelerate using the star's energy, burning off that sheath, revealing the metal beneath. And then we would take up a position at the nearest strategic point. The strategic point is Jupiter. The date is March 16th, 2026. On that day, NASA's Juno spacecraft, currently orbiting the gas giant, will have a front row seat. It will be there, watching as 3I Atlas glides past the Lagrange points. If Loeb is right, Juno may detect not just a comet, but debris, fragments, devices, sentinels taking up orbit. What would that mean? It would mean that we are not alone. It would mean that someone else, somewhere else, looked at the same Jupiter we see every night and decided it was worth a permanent watch. It would mean that our entire solar system has just become a landmark on a galactic map. The arrival trajectory of 3I Atlas contains one final, haunting detail. It arrived from a direction in the sky that coincides within 9 degrees with the origin of the WOW signal. That signal, detected in 1977, was a 72-second blast of radio energy so powerful and so narrow that it has never been adequately explained. It was humanity's first hint that someone might be out there. Now, nearly 50 years later, something has followed that same path. We are in a period of waiting. Between now and March, telescopes will continue to track it. Amateurs and professionals alike will watch for changes, for fragmentation, for any sign that the object is more than it seems. The key is the Hill radius. If 3I passes through that zone and simply continues on its way, the mystery will remain, but the threat, or the promise, will fade. But if it slows, if it releases something, if Juno detects debris where no debris should be, then the conversation changes forever. We are not looking at a comet. We are looking at a key turning in a lock. Jupiter is the door, and on March 16th, we may finally see what lies on the other side.
Did you like this mystery? And what is your theory? Leave your thoughts in the comments. And if you enjoyed it, then like and share. I'm Merc, and I'll be waiting for you in the next mystery.